When a chemical reaction happens, typically that reaction is going to fall into one of five different categories. So there's five different reactions that we need to be able to look at and say, oh, it's this type of reaction. So I want to start with a couple of the easier ones, and then we'll come back to these ones here. So if we come down here towards the bottom of page 13 in your notes, it talks about what are called synthesis reactions, okay? In a synthesis reaction, if you synthesize something, you're making something. You're making one thing. So you'll notice that in every single synthesis reaction, you're starting with two or more reactants, and those two things are coming together to form just the one. Okay, so anytime you have two or more reactants that all come together to just form one product, there can only be one product. That is a synthesis reaction. So the general formula is you have two separate things, and then they come together to form a new thing on the product side. Okay, and so you're going to have two or more reactants, and you're only going to have one product where it's all combined together. So when, for example, the first example, when hydrogen reacts with oxygen, it reacts and it makes water. In this case, calcium oxide reacts with water to make calcium hydroxide, and then carbon monoxide reacts with oxygen to make carbon dioxide. Notice that in each case, you only have one product, and when that happens, again, that is a synthesis reaction. Okay, the opposite of a synthesis reaction is a decomposition reaction. So notice it looks just like a synthesis reaction, but it's in reverse. You take one thing, and typically you heat it up, or it just does it all by itself, and it breaks into two or more things. So notice the examples here. They're the opposite of synthesis reactions, okay? So hydrogen peroxide, for example, just all by itself, breaks down into H2O and O2, okay? And that is another example of a decomposition reaction. So again, if you start with one thing and then end up with two or more things, again, those are decomposition reactions. Okay, so that's two of the five. Synthesis, you put two things together and you make one thing. Decomposition, you do the opposite. You take one thing and you break it apart into two or more things. And yes, all these examples only have two, but certainly you can have more than two. Okay, the third type of what's called a combustion reaction. And when something combusts, it means it burns, and it reacts with oxygen. Okay, it burns in oxygen gas. Okay, and again, usually when it happens, it's going to produce carbon dioxide and water. That's a real easy way to identify a combustion reaction. If you see O2, and then you see CO2 and H2O on the product side, 100% of the time, that's going to be a combustion reaction. I shouldn't say 100% of the time. 99% of the time, it's going to be a combustion reaction. Okay, but you'll notice here that if you take a piece of magnesium metal and you put it into a flame, it will burn, and it will react with the oxygen in the air and create magnesium oxide. Now, these three right here, I would expect you to know, oh, it's something reacting with O2, it's making CO2 and H2O. Those three, absolutely, 100% of the time, I would expect you to go, yep, that's a combustion reaction. This one, you might need a little bit more information, because if you think about like iron also reacts with oxygen to make this, and that's the chemical formula for rust. So sometimes things will react with oxygen. It's not combustion. Sometimes they do. So on this magnesium one here at the bottom, I would have to give you some more information. I would not expect you to know immediately that's a combustion reaction. But I might say something like, when magnesium burns in air, it produces magnesium oxide. What type of reaction is that? And you go, oh, it's burning in air. When it burns in air, it's reacting with oxygen. So that's a combustion reaction. But if I say you leave your wheelbarrow outside and then you come out in the morning after it's rained and it's all rusty, what type of reaction is that? Well, that's not a combustion reaction. What type of reaction is that? That is a synthesis reaction. And that does bring up a good point. So's this one. Sometimes a reaction can fall into more than one category. That magnesium plus oxygen one absolutely is a synthesis reaction. It's also, if I give you some more additional information, a combustion reaction. Okay, now let's go back up to the first two. These ones, I don't want to say they're more difficult, but the other three are pretty easy. Okay, here's where we have to start thinking just a little bit about, okay, what's actually happening here? Okay, in what's called a single replacement reaction versus a double replacement reaction. In a single replacement reaction, notice that you have one element by itself, and you'll notice what happens here is basically it trades places. Notice that the B is now by itself, and now A is with the X. Okay, so that is a single replacement reaction. Notice the zinc, what happens here? The zinc kicks out the hydrogen, and now the hydrogen is by itself, and the zinc is now with the sulfate. Okay, same thing here. Copper is by itself. It's going to kick out the silver. Now the silver's by itself, and now you've got copper nitrate. And then same thing in the third one. You've got chlorine by itself. Chlorine's going to kick out the bromine. The bromine is now by itself. So I'm not going to make you predict these products. I'm going to make you look at the overall equation and go, oh, here's the overall equation. What type of reaction is that? And you go, well, it can't be synthesis because they're not all together on the product side. It's not decomposition. It's not combustion. So it either has to be single replacement or double replacement. And again, in a single replacement, the key is one of those elements has to be by itself on the reactant side. Okay, because in a double replacement reaction, notice nothing is just by itself. Basically, you have two different ionic compounds, and very similar to single replacement, what happens is they just trade places. So the sodium now goes with the nitrate, and the silver here goes with the chlorine. Okay, so notice that in every example, the Na and the H are going to trade places. The Na goes with the Cl over here, and the H goes with the OH. And you're like, well, wait, doesn't that make HOH? Yes, it does, but isn't another way of writing HOH just H2O, which is just water? That's exactly right. Okay, and then our next one, the NH4, is now with the OH, and the Na is now with the Cl. All right, so let's look at some examples of these. So again, we've got 5 of them. We've got synthesis. I kind of put them in 3 categories. Synthesis and decomposition, and then combustion's kind of all by itself, and then we have, of course, single replacement and double replacement. Okay, so synthesis and decomposition kind of go together. Combustion's kind of all by itself, and then single and double replacement. Okay, so let's look at a few of these, and let's look at these examples that we have here. So, balance the following equations and state what type of reaction is occurring. So, in terms of our first example here, notice we have 2 potassiums and 2 chlorines, so there's a 2 right there. And that is, again, kind of start with synthesis and decomposition. If it's one of those, great. Then you don't have to worry about it. And then I kind of go to combustion after that. And then from there, I go to single and double replacement, if it happens to be single and double replacement. Okay, so this first one here, H2O making H2 plus O2. We need a 2 here and a 2 here. It's now balanced. And we're starting with water, and that's breaking apart into hydrogen and oxygen. So that absolutely is a decomposition reaction. Okay, in the second one, we've got 2 coppers. So we need 2 coppers here. That's all you need. And then you've got calcium by itself. Notice that it replaces the copper, and it kicks the copper out, so the copper's by itself. So that is a single replacement reaction. In this third one, let's see here. We've got, I see 3 strontiums, so 3 strontiums. I see 2 PO4s, so I'm going to put a 2 right there. And I believe that makes, count here with me, that's 6 hydrogens plus 6 more, that's 12 hydrogens. So we need a 6 there. And again, notice what happens here is that the hydrogen, or that the strontium now goes with the phosphate. So here we have the strontium with the phosphate. And again, the H goes with the OH, which remember, I think I erased it, but remember, HOH is the same thing as H2O. Okay, so the H goes with the OH, so nothing's by itself, so 2 things are being replaced, so that is a double replacement reaction. Okay, this next example, SO2 plus H2O makes H2SO3. I believe that is already balanced. Yes, it is. And it's two things coming together to form one. So that is a synthesis reaction. And then we've got we've got 6 carbons, 14 hydrogens, so we need a 7 there. That does create 19 oxygens all total on the right-hand side, so that is an odd number, so I'm going to go back to the very beginning and double everything. So that becomes a 12, that becomes a 14. And just doing some quick math here, 12 times 2 is 24, plus 14 is 38. So that means we need 19 O2s. Okay, and that is, again, something reacting with O2, making CO2 and H2O. Again, 100% of the time, that's going to be a combustion reaction. Okay, in our next one, we've got 2 NO3s, so we need a 2 there, and then a 2 there, so it's balanced. And we've got one element by itself, and notice that that copper replaces the sodium, so that is a single replacement. And here we've got H3N, and here we have H2. So we need to do 2 and then 3. That's equation's balanced now. And we're starting with one thing, and it's breaking into 2 or more. So that is certainly a decomposition reaction. And then our last one, again, similar to the C6H14 one, it's reacting with O2 to make CO2 and H2O. So that's going to be combustion. Now, in terms of balancing, we need, we need 14 CO2s. We're going to need 15 waters, but now again, we have an odd number. We have 43 oxygens on this side, so we've got to come back, double everything to get our odd number into an even number. So that's 28 CO2s and 30 waters. So 28 times 2 is 56, plus 30 is 86 oxygens all total. So we need 43 O2s on that side. Okay? And so those are all just a few examples of balancing an equation, and then even without balancing it, you should be able to look at it and determine synthesis or decomposition, okay, is one category. Combustion, its own little special category. Again, look for the O2, look for the CO2 and the H2O. If it's something other than that, then I'll give you some more information. Remember, like this one here. Okay, and then our final category are the single replacement and the double replacement reactions. Okay, and again, a single replacement, remember, single means one element has to be single. That element has to be by itself. In a double replacement, no elements are by themselves. They're both positive and negative with positives and negatives. Okay? And that's our lesson for today.